In aviation, clear visibility is paramount, especially during critical phases like landing and taking off. However, certain conditions can dramatically reduce visibility, turning routine maneuvers into high-risk situations. One such phenomenon, particularly perilous for helicopters, is known as a brownout. Imagine a helicopter descending for a landing in a desert environment. As the powerful rotor blades churn the air, they create a swirling vortex that engulfs the aircraft. This vortex kicks up sand and dust from the ground, forming a dense, opaque cloud that rapidly engulfs the helicopter. This blinding phenomenon, aptly named a brownout, significantly reduces visibility, disorienting the pilot and jeopardizing the safety of the aircraft and its occupants. Brownouts can occur anywhere. Loose particulate matter like sand, dust, or snow exists on the ground. The danger of brownouts lies in their sudden onset and disorienting effects. Understanding the dynamics of brownouts and employing appropriate mitigation techniques are crucial for ensuring safe helicopter operations. Helicopters, with their unique ability to take off and land vertically, are indispensable for a wide range of operations. However, this maneuverability comes at a price, particularly in environments prone to brownouts. During landing, as the helicopter descends close to the ground, its powerful rotors displace a significant volume of air downwards. This downward airflow, known as the rotor wash or downwash, interacts with the ground, creating a turbulent vortex that engulfs the aircraft. In areas with loose surface materials like sand, dust, or snow, this rotor wash kicks up a blinding cloud, leading to a brownout. The reduced visibility during a brownout poses significant challenges for pilots. It becomes difficult to accurately judge distance and altitude, increasing the risk of a hard landing or even a crash. The swirling dust and debris can also affect engine performance and damage sensitive helicopter components. Understanding the dynamics of brownout formation and employing appropriate mitigation techniques are crucial for ensuring the safety of helicopter operations. Several factors contribute to the likelihood and intensity of a brownout, turning a routine landing or takeoff into a potentially hazardous event. Understanding these factors is crucial for pilots to assess the risk and take appropriate precautions. One significant factor is the type of soil or surface material present. Loose, dry particles like sand and dust are more easily lifted by the helicopter's rotor wash, leading to denser brownouts. Conversely, hard-packed surfaces, or those with vegetation cover, are less susceptible to brownout formation. The size and weight of the helicopter also play a crucial role. Larger, heavier helicopters generate a more powerful downwash, resulting in more severe brownouts. The helicopter's approach speed and angle of descent also influence brownout severity. A steeper descent angle and higher speed will create a more powerful downwash, increasing the likelihood and intensity of a brownout. By carefully assessing the conditions and adjusting their approach accordingly, pilots can minimize the risk of encountering a severe brownout. Operating a helicopter in a brownout environment demands unique skills and heightened awareness. Pilots use various techniques to mitigate risks in these conditions. Approaching the landing zone with caution is crucial. A shallow approach angle and reduced airspeed help minimize dust. Maintaining situational awareness is paramount. Pilots rely on instruments to monitor altitude and descent rate. Advanced technology assists pilots during brownout conditions. Terrain awareness and warning systems provide crucial alerts. Infrared cameras and sensors offer a clearer view of the landing zone. Training is essential in mitigating brownout risks. Brownouts present a unique challenge to pilots due to the sensory illusions they can create. These illusions, often disorienting and misleading, can lead to spatial disorientation and increase the risk of a mishap. One common illusion is the leans, where a pilot perceives the aircraft to be banking in one direction when it's actually level. This illusion occurs when the pilot loses visual cues from the horizon and relies solely on the inner ear's balance mechanism, which can be fooled by the swirling dust and rapid changes in altitude. Another illusion is the Coriolis effect, which occurs when a pilot makes a head movement during a prolonged turn. This movement can create a false sensation of rotation in another axis, leading to disorientation and difficulty controlling the aircraft. These illusions highlight the critical importance of relying on flight instruments during a brownout. Pilots undergo specialized training to develop the skills and mental discipline to overcome these sensory challenges and make safe decisions in these high-stress environments. The dangers of brownouts are not merely theoretical, they represent a persistent and costly reality, particularly for military operations. Military helicopters, often operating in desert environments and carrying heavy payloads, are particularly susceptible to brownout conditions. History is replete with examples of brownout-related accidents, highlighting the severity of this hazard. During the 1991 Gulf War, brownouts were a significant factor in helicopter accidents. The fine, powdery sand of the Iraqi desert created blinding dust clouds, leading to numerous incidents and highlighting the need for improved training and technology to mitigate these risks. In 2005, a US Army Chinook helicopter crashed in Afghanistan during a brownout, resulting in the loss of 16 service members. Statistics paint a stark picture of the brownout threat. A study by the US Army Safety Center found that brownouts were a contributing factor in approximately 25% of all Class A helicopter accidents. These incidents highlight the importance of continued research and development of technologies and training programs to reduce brownout risks. While brownouts remain a significant hazard in aviation, advancements in technology and pilot training offer hope for fewer incidents. Advanced sensors like radar and LiDAR can see through dust clouds, providing pilots with a clear picture. These systems enhance situational awareness and reduce the risk of accidents. Autonomous landing systems use sensors and algorithms to guide helicopters safely. Pilot training evolves with advanced simulators to practice emergency procedures. Investing in these advancements creates a safer environment for all.